So this is the 13th session on rigid body kinematics. So in this session also I'll take up a numerical problem on rigid body kinematics involving SRC procedure for velocity. So in this problem I'll also discuss different ways of solving a given problem. Okay. Only SRC method will not be used, but other techniques will also be used to solve the given problem. Section formula for velocity will also be used, as was discussed in the 12th video on rigid body kinematics. Okay. So if you know the theory of this chapter, then you can directly come to his 13th session. But if you don't have the idea of theory, then you must first refer to the 7th and 8th video on rigid body kinematics, then come to this video. Okay, fine. So I'll take up a problem on rigid body kinematics. I'm writing the problem here. Fine. Problem is this: R1 and R2 are two identical rods each of length 12. The rods can move in vertical xy plane. Left end of rod R1 is hinged at origin flexibly left end of rod R1 R2 is constrained to move along downward y direction. The two rods are hinged as shown. The joint of the two rods is flexible. Joint of the two rods is flexible. At time t barabar 0, both the rods coincide with x-axis. Both the rods coincide with x-axis and are released from rest. The two rods begin to move down under the influence of gravity. Under the influence of gravity. Okay. Question is, find the speed of center C2 of rod R2 in terms of omega L and theta. Omega and theta will be specified. What is omega and what is theta? Alright, by several methods. Okay, fine. I'll rub this one, okay, fine. This I'll rub it. Every detail is given here. So first what I'll do, I draw the diagram of the situation, okay. Diagram is this. This is the horizontal x-axis rightward. This is the origin. This is the downward y direction. This is vertical xy plane. Initially both the rods overlap with the x-axis. So both the rods are shown here. This is rod R1. This is rod R2. This is the flexible joint of the two rods. This is the flexible joint of the two rods. This is the origin of the coordinate system. So this is the situation at time 0. Okay, fine. Now I rub this one. Now, when the rods are released from rest in vertical plane, they begin to move down under the influence of gravity. R1, left end of rod R1 is pivoted at origin O flexibly, and this is a flexible joint. Left end of rod R2 is constrained to move along a downward y direction. Okay, so this is the situation at time 0. Situation at time t is this. Again, I draw the coordinate system. At some time t, rod R1 has come to like this because its left end is fixed at origin flexibly. So rod R1 has turned through an angle theta. Rod R1, okay. Length of rod R1 is 2L. 2L is the rod length of each rod. Now left end of rod R2 is constrained to move along y direction. So at time t, rod R2 is something like this. This is the rod R2. This is the flexible joint of the two rods taken to be the point A1. This is the flexible joint. This is the contact point A2. R2 is constrained to move along y-axis. Its left end is A2. Okay. Now one more thing. Rod R1 has turned through an angle theta. It's undergoing pure rotation about the origin O. It is undergoing pure rotation about the origin O. So rod R1 has acquired some angular velocity omega d theta by dt. Okay. Now by alternate angle, this theta, this is also theta. Now this angle will be 90 degree minus theta. This is 2L, this is also 2L. This is isosceles triangle. So this angle will also be 90 degree minus theta from geometry. If you draw normal here, this also becomes theta. So rod R2 also has turned through an angle theta, but initially rod R2 was like this. It has become like this. So it's rotating in anti-clockwise sense, and angular velocity of R2, angular speed of R2 is same as that of R1. So omega. Why so? Why? Because both the rods have turned through same angle theta. Both the rods have turned through the same angle theta. So angular speed of both the rods are same, omega say. But sense of the angular velocity of two rods are opposite. R1 is rotating in clockwise sense and R2 is rotating in anti-clockwise sense. Alright. So R1 is rotating in clockwise sense, R2 is rotating in what? Anti-clockwise sense. So it's something like this. Alright. Now A1 is the common joint of the two rods, flexible joint. A2 is the left end of rod R2 moving downward. Alright. And this is the situation at time 0. Fine. Now what we have to do, first thing, what we have to calculate. First thing is that this. Find the speed of point A1 and A2 in terms of omega, L and theta. Find the speed of point A1 and A2 in terms of omega, L and theta. Terms of omega, L and theta. Okay. I'll grab this one. Now how do you find the speed of point A1? See, point A1 is a common point of both the rods, R1 R2 both. So you can see that distance of A1 from point 2 is constant, 2L, and O is fixed in ground. So with respect to ground, A1 is moving in a circular motion with center at O and radius 2L, and angular speed of circular motion is omega clockwise. So by theory of circular motion kinematics, speed of A1 will be 2 omega L, omega into radius, omega into 2L. Okay, so speed of A1 is first, speed of A1 is VA1 equal to 2 omega L. Also, velocity of A1 will be normal to the radius vector of the circle. This is the radius vector. So speed of A1 will be something like this, 2 omega L V1. VA1 I have written here, here I have written V1, they are same, alright. And the velocity is right angle to the rod radius. So this is right angle to the rod OA1. This is the speed of A1. Okay, one thing has been done. Also, you have to find the speed of point A2 in terms of omega, L and theta. One thing you note, A2 is moving along y-axis. Okay, so its velocity is equal to dy by dt, where y is the y coordinate of point A2. So, if you see what is the y coordinate of point A2, this is the y coordinate of A2. So this is equal to this plus this. This is 2L, this is theta, this is 2L sine theta. This is theta, this is 2L, this is also 2L sine theta. This is 4L sine theta. So speed of point A2 is V2. I write here VA1, I write here V1, they are same. Okay. So for speed of A2, don't write VA2, I write V2 itself. That is just equal to d by dt of this distance. This as I discussed just now, this is 4L sine theta. 4L sine theta, okay. So this becomes 4L comes outside. So I'll write here. V2 is equal to 4L into d by dt of sine theta. This becomes 4L into d by d theta of sine theta into d theta by dt. And this becomes cos theta, this becomes omega. 4L cos theta into omega. So this becomes 4 omega L into cos theta. This is V2. Fine. So one first part of the question has been solved. And direction of V2 is vertically downward in along positive y direction. So one question has been solved. Okay. Now second point is this. Also C2 is the center of rod R2. C2 is the center of rod R2. Now second question is find VC2. We have to find the speed of center C2 of rod R2 with respect to ground. So find VC2 and in terms of omega L and theta by several methods. Okay. VC2 denotes the center of speed of center C2 of rod R2, this order. Okay, by several different methods. Fine. So several methods I'll write down. So method 1, the method of coordinates. See, if you don't even know SRC for velocity, then also you can solve such questions, okay, by using different concepts as I am doing it here. Method 1 is this. We solve it using the method of coordinates. Method M1. First method M1, okay. Method 1, M1. By method of coordinates. By method of what? Coordinates. And by method of coordinates, what we'll do? We'll write down the x and y coordinate of center C2 in terms of L and theta. And then find the x and y components of velocity of C2 by differentiating the respective coordinates with respect to time. And then root Vx square plus Vy square. Alright. So now, first what you have to do, you have to find the coordinate of center C2. X and y coordinate. So let the x and y coordinate of center C2 at time t be x comma y. Okay. Now what is x coordinate? X coordinate is this distance by geometry. Okay. If you now drop a normal from here to here, this distance is just the x coordinate of C2. That is same as now this angle is how much? Theta. If I draw here, this also becomes theta. This is 2L. This is center. This is L. X coordinate of C2 becomes how much? This distance. That is same as this distance. L cos theta. So x coordinate of C2 is how much? X L cos theta. That is the x coordinate of point C2. Alright. Now we also want to know the y coordinate of C2. Now how much is the y coordinate of C2? We drop a normal from C2 on this y axis. This distance is the y coordinate of C2. That is equal to this distance plus this distance. This distance plus this distance. This distance will be how much? This is L. This is L sin theta. And this distance is how much? 2L sin theta. This distance same as this distance. This is 2L theta. This is 2L sin theta. This is also 2L sin theta. This is equal to L sin theta. This distance is 3L sin theta. So y coordinate becomes 3L sin theta. Alright, fine. So x coordinate of C2 is L cos theta and y coordinate of C2 is 3L sin theta. Now speed of center C2 by method of theory of particle kinematics of point is root under Vx square plus Vy square. Alright, fine. So this I have here. So I write here, now to know Vc2 you must know Vx and Vy. So Vx is simply dx by dt by theory of particle kinematics. D by dt of x is just equal to how much? L cos theta. L comes outside. D by dt of what? Cos theta. So this becomes d by we apply the chain rule into how much? D theta by dt. This becomes L. D by d theta of cos theta is minus sin theta. And d theta dt becomes omega. Minus omega L sin theta. This is Vx. Negative sign shows that x coordinate of velocity of C2 is not rightward but along negative x direction, that is leftward direction. Okay. Now what about Vy? Vy is dy by dt. Okay. So this becomes d by dt of what? 3L sin theta. Now 3L comes outside. 3L d by dt of what? Sin theta. This becomes 3L d by d theta of sin theta into d theta by dt. Now this becomes cos theta and this becomes omega. So 3 omega L cos theta. Okay. So Vy has also been found. Fine. Now I have this one. So now Vc2 is equal to root under Vx square plus Vy square, that is root under minus omega L sin theta whole square 3 omega L cos theta whole square. So omega L comes outside. So this becomes sin square theta plus 9 cos square theta this becomes, simplifying it, if you write sin square theta as 1 minus cos square theta, then this becomes 1 plus 8 cos square theta. This is the answer to the first part of the question. Second part of the question by method of coordinates. Okay, fine. So this was solved by method 2. Okay. Now, what is the third part of the question? Now this I'll rub it, fine. Now method 3 is this. Method 3. Method this was first method. Method 2 is by section formula for velocity. By section formula for velocity. By section formula for what? Velocity. Now, section formula for velocity, theory of this section formula for velocity has been discussed in the 12th video on the rigid body kinematics. In case you have doubt about the theory of this method, you can refer to the 12th video, previous video of rigid body kinematics. There you will get it. All right. So, VC2, now C2C, if we consider rod R2, then A2, C2 and A1, they are all the material points of rod R2. And C2 lies is the midpoint of the rod A1, A2. So from section formula for velocity VC2, velocity of center C2 of rod R2 is equal to lambda times C2 is the midpoint. So first I'll write down the formula. C2, suppose let's read. See, C2 section formula I use. So you can see this, that A2 C2 by A1 C2 is just equal to 1 by 1 because it's the midpoint. C2 is the midpoint of A1 A2. So this means lambda is equal to mu is equal to 1. Okay. Now I write down the section formula for VC2 is equal to, here lambda is this and mu is this. VC2 becomes, this is lambda, this is mu. Lambda times V1 plus mu times V2 by lambda plus mu. So lambda and mu are both equal, they cancel out. So this becomes V1 plus V2 by 2. This is VC2. Alright. So VC2 becomes 1 by 2 root under V1 square plus V2 square plus 2 V1 V2 cos alpha. Alright. What is V1? V1 is the speed of A1. So V1 is simply 2 omega L. V2 is the speed of A2. V2 that we have just found in method 1 also. V2 this one. So that is equal to 4 omega L cos theta. Alright. Now what is alpha? Alpha is the angle between the vector V1 and vector V2. V1 is this, V2 is this. Angle between V and V2, that is alpha. Now alpha we have to determine in terms of theta. Alright. Alpha has to be determined in terms of what? Theta. Alpha to be determined in terms of theta. We have to determine alpha in terms of theta. Okay. So now how do we find alpha? So see, this is velocity of A2 is V2 in downward direction. This is V1. This is right angle to this OA1. This V2 I draw here. This angle will be alpha. Is it alright? Fine. Clear? Now see, now you have to find this value of alpha. Okay. So how to find alpha, that is the question. So you can see this is theta theta, this is right angle. So this becomes how much? This becomes how much? This becomes this is 90 degree. This is theta, this is theta. So this becomes 90 degree minus 2 theta by geometry. And this is alpha. Okay. So we have to just determine alpha from geometry. Okay. So this is theta, this is 90 minus 2 theta plus alpha. This plus this is equal to 90 degree. Fine. This angle plus this angle plus this angle adds up to how much? 90 degree. This is horizontal, this is vertical, this is 90 degree. This plus this is equal to 90 degree. So we write it like this. This angle is theta. 90 degree minus 2 theta plus alpha is equal to 90 degree. You will cancel out. So alpha is just equal to theta. Fine. Alpha is just equal to how much? Theta. This will substitute in this formula. Then we get VC2. Alright. This will rub it fine. So this also will rub it, okay? So VC2 becomes root under V1 is 2 omega L, 2 omega L whole square plus V2 is how much? 4 omega L cos theta plus 2 times 2 omega L 4 omega L cos theta into cos alpha. Alpha is just theta. Cos theta. This entire thing is inside the root. Divided by 2. Now 2 omega L you can see is common. 2 omega L, take it outside. 2 omega L by 2 root under 1 plus. So 1 plus 2 cos theta whole square. And this becomes 2 omega and 2 omega L, take common. How much will it become? 2 omega L into 2 omega L. That is outside. So it becomes how much? It becomes 2 into 2. It becomes 4 cos square theta. Okay. So this becomes omega L root under 1 plus 8 cos square theta is therefore the required answer by method by the section formula method. Okay. So omega L is equal to root under 1 plus 8 cos square theta. Fine. So omega becomes speed of center C2 of rod R2 becomes omega L root under 1 plus 8 cos square theta. That is the speed of center C2 of rod R2. Alright. So this was a method 2. Okay. Now we'll discuss by method 3. Method 3 is by SRC. Method 3 is by SRC, procedure for velocity by SRC. Now this method, SRC method, we will subdivide it into 4 different cases. Sub case A, we apply SRC between A1 and C2 and select A1. SRC between C2 and A1 and selecting A1. B is SRC between C2 and A1 and selecting C2. C, SRC between C2 and A2 and selecting A2. And D is SRC between C2 and A2 and selecting C2. So 4 subcases will come in method 3. Alright. So method 3, 4 different cases arise A, B, C, D. Now we solve the problem by using each of these methods. Alright. Now this I have it fine. In case you are not familiar with SRC method, you go to the 7th and 8th video of rigid body kinematics. There you will get the theory of SRC method. In great detail it has been derived. Okay. So, this is sub case A. We apply SRC between C2 and A1 and we select A1. So, SRC between C2 and A1 and selecting A1. So, first what do you say? SP arrow C2 A1 and OP arrow C2. SP meaning selected point and OP meaning other point. Now we draw the line joining C2 and A1, whose orientation is same as in the problem. So this line is rod R2, that is itself the line joining C2 and A1. So I draw the line here, like this. Okay. And this is the rod R1. Now this is C2. This is equal to, this is the A1. So what we do in this action, we give the velocity of A1 to C2. Now velocity of A1 is this, 2 omega L at right angles to rod R1. This angle is 2 theta, this is 90, this is equal to 90 minus 2 theta. We give the speed of A1 to C2. Speed of A1 is 2 omega L. We give 2 omega L to C2. Now we write down the sentence. Sense of rotation of omega of rod R2 is anti-clockwise. So C2 moves in anti-clockwise circle with center at A1 and radius equal to L. So we give speed of omega into L, right angle to this. So like this. Second action is this. Now third, we have to combine these two. Okay. So we have to take the vector sum. For this we need the angle, this angle. Now this is 90 minus 2 theta, this angle. So this angle will also be how much? 90 minus 2 theta. And this is right angle. So this angle becomes how much? 90 degree minus this. That just becomes 2 theta. Alright, fine. So now we combine these two vectors. If we combine these two vectors by parallelogram law, we get the speed of C2. The center of speed C2 is root under vector sum of these two. We apply the parallelogram law of vector addition. So this becomes omega L whole square plus 2 omega L whole square, 2 omega L into 2 omega L into cos of 2 theta. So omega L becomes common. 1 plus 4 cos 2 theta. This becomes omega L root under 5 plus 4 2 cos square theta minus 1. So this becomes omega L root under 5 plus 8 cos square theta minus 4. That is same as the answer which you obtained by other methods also. This becomes omega L root under 1 plus 8 cos square theta. This is therefore the required speed of center C2 of rod R2. So VC2 becomes omega L root under 1 plus 8 cos square theta. This was the sub case A of method 3. Alright, fine. Now I have this one. Okay. Now subcase B. Subcase B, we apply SRC between C2 and A1 and we select C2. SP arrow C2 and OP arrow A1. Okay. Then you draw the line joining C2 and A1. That is rod R2 itself. So this is the line they see. Okay. This is the joint. This is the point A1. This is C2. Now we give the velocity of C2 to A1. Now direction of motion of C2 is not known. Direction of motion of C2 is not known. So what we do? We write down the components of C2 in x and y coordinate. Okay. So I write here Vx and Vy. So what we do in this? We give the velocity of C2 to A1. The velocity of C2 is the vectors of these. So we give these two velocities we give to A1. Vx and how much? Vy. Okay. Now sense of omega of this rod R2 is what? Anti-clockwise. Alright. Now what do we say? Other point A1 moves in anti-clockwise circle with center at C2 and radius equal to this distance C2 A1 L. So what do? We give a speed of omega L to A1. Omega L to A1, this will be like this. At right angles to this rod R2. Okay. The velocity of A1 is the vector sum of these three. That is the velocity of A1. Alright. Now we know from the part 1 of the question that velocity of A1 is how much? 2 omega L at right angles to rod R1. So I will draw another diagram here. See, this is R1, okay, this is theta, this is also theta, this is A1 joint, okay. Velocity of A1 is 2 omega L at right angles to rod R1, okay. So vectors of these three should be equal to this much. Now what do? We use the component method. We resolve this into horizontal component, vertical component. If you resolve this into vertical component, horizontal component becomes how much? This is how much angle? This is 90, this is 2 theta. This becomes how much? 90 degree minus 2 theta, this angle becomes, okay. So velocity of A1 in x direction becomes 2 omega L into cos of this. 2 omega L into cos of this angle which this makes with horizontal direction. So x component of velocity of A1 is 2 omega L cos of 90 minus 2 theta plus theta. Okay. This is the x component of velocity of A1. 2 omega L cos 90 minus 2 theta plus theta. This is in leftward direction. And x component of A1, velocity of A1 can also be written as sum of x component of these three terms. Now what is the x component of this one? Tell me. This is theta. This is also theta. This is 90 degree. Okay. So how much will be this angle? So this will be written as omega L. Now this is 90. This is theta. Okay. This angle is also how much? 90 degree minus 2 theta. This angle how much? This one. Okay. Fine. So x component of this will be how much? Will be equal to omega L cos of 90 minus 2 theta plus theta plus x component of this Vx, that is the rightward direction. This becomes minus Vx. Okay. Now this is how much? 2 omega L cos 90 minus theta. 2 omega L sin theta becomes omega L sin theta minus Vx. That means Vx becomes minus omega L sin theta. This is Vx. Now we have to know Vy. The y component of velocity of A1 is 2 omega L into sine of this in downward direction. Alright, fine. So now, so downward direction, okay, this I'll have this much, okay, because the space is not there. Then I write down the y component. Y component of velocity of A1 is 2 omega L sine of this angle in downward direction. So 2 omega L sine of 90 degree minus 2 theta plus theta. That is same as the y component of velocities of these three terms, sum of these three terms. This has downward direction Vy. This has no, Vx has no y component. And this y component is in upward direction. That is minus of omega L. And this is 90 minus 2 theta plus theta. 90 degree minus 2 theta plus theta. So this becomes 2 omega L sin 90 minus theta cos theta is equal to Vy minus omega L. This also becomes cos theta. So Vy becomes how much? 3 omega L cos theta. Okay. And Vx is this. So velocity of C2 is root under Vx square plus Vy square. Alright. Fine. So if you substitute here, the velocity of C2 is simply root under Vx square plus Vy square. Now Vx is how much? Vx is minus omega L sin theta. Minus omega L sin theta whole square. And Vy is 3 omega L cos theta. 3 omega L cos theta whole square. Now we take omega L common. Minus goes away. Minus into minus becomes plus. Sin square theta plus 9 cos square theta. So this one simplifying becomes how much? 1 plus 8 cos square theta This is the answer to part B of the question. Alright. Part B method, okay. So this alpha bit, okay, fine. Now use part C. Part C is SRC between C2 and A2 and selecting A2. SRC for velocity between C2 and A2 and selecting what? A2. Okay. So here what we do? SP arrow meaning what? SP arrow A2. Okay. And OP arrow what? C2. Alright. Now you draw the line joining SP and OP, that is C2A2. That is rod R2 itself. This is the rod R2. This is C2 here. This is A2 here. Now what do we do next? We give the velocity of A2 to C2. As found in part 1 of the question, velocity of A2 is 4 omega L cos theta downward direction. So we give a velocity of 4 omega L cos theta to C2 in downward direction. Now we handle that rotation term. Since omega of rod R2 is omega anti-clockwise, the C2 moves in anti-clockwise circle with A2 as the center and radius L. So from that we give a speed of this much, omega L to C2, normal to the rod A to C2. Okay, and then C2, velocity of C2 is the vectors. We have to combine these two terms vectorially. Velocity of C2 is the vector sum of these two. Now this angle is theta. So this angle becomes 90. This is 90 minus theta. So this angle becomes how much? 90 minus theta. This is 90 minus theta. This is 90. So this angle becomes how much? Theta. It has to be theta, because so that the sum of these three becomes how much? 180 degree. So VC2 is the vector sum of these two. So root under. I hope it is fine. So this angle is how much? Omega L whole square, parallelogram of vector addition, plus 4 omega L cos theta whole square, 2 into omega L into 4 omega L cos theta. Angle between omega L and 4 omega L is this angle, 90 plus 90 minus theta, that is cos 180 minus theta. Sorry, cos 180 minus theta. 180 degree minus theta. So this becomes omega and I take common. This entire thing is inside the root. It becomes 1 plus 16 cos square theta. And here this becomes minus cos theta. And becomes how much? 8. It becomes 8. Cos 180 minus theta is minus cos theta, and this is cos theta, minus 8 cos square theta. So the same answer I obtained again. Omega L root 1 plus 8 cos square theta. This is the answer to by method 3. As I apply SRC between C2 and A2 and selecting C2. Alright. This is also error bit now. Now D is, we apply SRC between C2 and A2 and select C2. SRC between C2 and A2 and selecting C2. Okay. So SP arrow C2, OP arrow A2. Alright. Now we draw the line joining C2 and A2. That is just the rod R2 itself. So this is C2 and this is A2. Alright. Now we give the velocity of C2 to A2. Now motion direction of C2 is not known. So what we do, we resolve its velocity into two components, Vx and Vy. Actually you can take Vx in left rod also, or you can take right rod also. If you assume an opposite direction, on solving you get a negative sign. So there is no problem about that. Whichever you want you can take it. Now we give the velocity of C2 to A2. So we give Vx and Vy to A2. Now we write down the rotation term. This is SP, this is OP. A2 moves in a anti-clockwise circle because this is rotating anti-clockwise. Na? A2 moves in anti-clockwise circle with center at C2 and radius L. So to A2 we give a velocity of how much? Omega L. Okay, this is right angle to this rod. C2 A2, it is right angle. Now velocity of A2 is the vector sum of these three. But we know that velocity of A2 is how much? 4 omega L cos theta in downward direction. So sum of downward components of these three will add up to 4 omega L cos theta. Now this has no downward component, it is horizontal. Downward component of this is how much? Now this is theta. This is 90 minus theta. So this becomes also how much theta? The downward component of velocity of A2 is sum of downward component of these two. So omega L cos theta plus Vy. That is same as how much? 4 omega L cos theta. As was found in part B of the question. So Vy becomes 3 omega L cos theta. Okay. And what we have to find Vx now. The velocity of x component of velocity of A2 is 0 because it is moving in vertical downward direction. So x component, some of these two x components of these two should also add up to 0. So Vx plus omega L sin theta. X component of this is omega L sin theta. That adds up to 0. Vx becomes minus of omega L into sin theta. This is Vx and this is Vy. The velocity of C2 again becomes how much? Root under Vx square plus Vy square. So this becomes minus omega L sin theta whole square plus 3 omega L cos theta whole square. Okay, and this when you simplify you again get the same solution. You get the same answer again. Fine. So this becomes how much? If you take omega L common, minus sin theta whole square becomes sin square theta. And this becomes 9 cos square theta. And this when you simplify it becomes 1 plus 8 cos square theta is therefore the required answer. So this was the method 3. ABCD sub 4 subparts of method 3. And method 4 is by using the IC concept, instantaneous center of rotation. That will be discussed in the successive coming videos. Okay. So by using IC concept to be discussed later. Using IC concept. IC meaning what? Instantaneous center of rotation. That will be discussed in the coming videos. Okay. In that I'll discuss this one. Okay. So this was the 13th video on rigid body kinematics. So in this also I have discussed a problem on this SRC project for velocity. If you go through it properly, understand it, and then you take up questions, similar type of questions, you'll be able to solve it. There's no doubt about it. Okay. Whether it's JEE Mains, JEE Advanced, or it is NEET, you can easily solve it. Fine. So just close it here.